Hello everyone, this is Ahmed Najjar back again. In this video tutorial, it's a geometry nodes tutorial. So the purpose of this tutorial is to show you how can we place or instance bolts on the corners of any let's say object that you have. As we can see here, we have this cube, and on each corner of the cube we have one bolt, and the same thing for this ecosphere, where we have a bolt on each corner of the faces that makes this ecosphere. So one of the cool things that we can do also is that we can control the corner offset, so we can get the bolt's location either to the middle of the face or to the corners, the same as here for this object. So we can control the corner offset, as we can see here. We can also control the size of the bolts, so we can increase or decrease the size of the bolts, and also the length or the depth, let's say, of the bolts. So these are mainly cylinders, so it has been placed with specific geometry on the corners of the object. Again, for the materials, you can play with the materials. As we can see here, these are the materials that I have made, but you can select any materials of your own choice. So before we start, please hit the like button, the subscribe button, and let's get started. So I'm gonna close everything here, file, new, general, don't save, and let's move to the new scene. As we can see here, this is the default cube as usual. I'm gonna just go ahead and open the geometry nodes editor, and we will start by actually building our own geometry nodes. So this cube, as we can see it here, I'm just gonna hide the extras so the light and the camera don't come in our way. This is the cube, and let me just again enable the wireframe so we can see what's going on with us. This is the wireframe, or the visibility of the edges. The first thing that we will do actually to move a little bit, or to give ourselves a little bit of offset into the face, is to split the edges of each face or of this object. When we split the edges, we can have, let's say, a same copy of the object but with splitted pages. So if I go to mesh right now and split the edges, we will get this. Let me show you what we will get. If I go and select geometry nodes, join geometry, this is the original. The first one is the original, the second one is actually the mesh after we split the edges. So if I remove this now, the original one, we still have the same, as we can see here, but each face as an island. So each face has its own properties right now. It's not like all the faces are controlled by each other. The evidence of this is that if I go now and get scale elements node, mesh, scale elements, here it is, okay, and if I decrease the scale a little bit to 0.9, this is what we will get. So we get actually the original cube and a separate mesh that is each face is smaller by 0.1 size. So we get this, and from here we can start getting actually our bolts into the corners of the new faces. So the corners of the new faces are actually the targets that we will hit right now to place the bolts wherever we want on these corners. And I can control the scale, as you can see here, by just scrolling the scale into up and down. Okay, now the question is that how can we reach the face corners, or what we need to do actually. We need to place points first of all on each face corner. So I need points, so I'm gonna get some points here, but these points we need to know the exact count of them, and the exact count should be the exact count of all the new faces corners. So 0, let's say, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So we need to get this information actually, but how can we get it? So let's first tell you how can we get this with a node that is called domain size. Okay, and if you plug the second geometry after we split it and after we scaled it, this is the geometry that we need, and this output here gives me the face count, the face corner count, edge count, point count. What we really care about is the face corner count. So I'm gonna place points. The count of these points will be equal to the face corner counts. Okay, and now if I put this here, you will see that there will be some points generated, but where are they? If I go to let's say wireframe or X-ray, you will see that the points are there, but it's all positioned actually in the center of, as we can see here, the position 0, 0, 0. So to move them to be placed into the face corner places, we need to get the position of these face corners. How can we get that? We can get that by actually one of the good nodes, which is called let me check. So Shift A, I will get the position of these points, okay, of these face corners. So let me bring the input position first. We need the position, but we need it at this level before we actually move to any other part. So that can be achieved by a node called transfer attribute. So once we bring the transfer attribute node, we will have it there. So Shift A, attribute, transfer attribute, and the source geometry is this geometry. Okay, what are we trying to get? We are trying to get a vector as a position, and we need the I think the index, or let's see. So what attribute I'm gonna collect here is the position. So the position goes to the attribute. Okay, and to get actually the face corners, we need to go and select from here index and select the face corner domain. So this attribute now, the position of the face corners, I can get it out of the output of this transfer attribute node, and I can simply plug it into the position here. So we see now that the points has been distributed exactly to where we want them to be on the face corners. If I decrease the scale now, you see that on each face corner we have a single point, and the total number of points equals to the total number of the face corners that we have. Then the next step is actually to instantiate or put some instances on the points that we have. So if I go now and get instance on points, plug it, and then select cylinder as primitive mesh cylinder. We need only 6 vertices, and we can control the radius and depth of this cylinder later on. Okay, so if I put this as the instance here, you see that we have a cylinder everywhere, but because it's very big, we can decrease the size. So I'm gonna control the radius a little bit and control the depth, and we see that this cylinder right now is placed on each corner, but we have a problem. The problem is that the rotation of this cylinder does not match the normal of the faces, or doesn't fit into the space or onto the surface of the faces. So what we will do is actually control the normal or control the rotation of these using one of the features that we also gonna use the transfer attribute as well for it, from this mesh, the mesh after we split it. And this time I'm gonna take the rotation. So it's not the position, it's the rotation, but the rotation is actually based on the normal of that face. So give me the normal as an input. Normal, this is the attribute that I will use. Okay, and then we will bring this into the rotation, but first we need to convert it to degrees. To do that, we will use the vector, I think, or the utilities align Euler to vector. So I'm gonna select this, and we will take the normal as the vector, the attribute as the vector, and the rotation we will keep it as it is. But if I plug it now into the rotation, it won't give me what I expect, as you can see here. Let me just remove this. Now we have everything here. But if I change it to Z, it takes the Z normal of each face and it rotates and places the bolts into the Z normal. So exactly this is what we want, but without showing this anymore. So we need to remove from the join geometry the splitted image. So here it is, as simple as this. Now the rest of the things are actually some enhancements to make it better. So for example, if we go to this cylinder and if we increase the depth a little bit, it goes into both sides. So if I enable this X-ray, you will see that it scales into both sides. So we need to scale it into a single side, and we need it to start from actually the touch point with the face. So simply we can transfer that cylinder before we instance it. So geometry transform. Okay, and what we will get is we need to have the depth divided by 2 and translate it on the Z. Okay, so we will take this now and put it into the input. This is the depth. Let's get it from an input. Shift D. I'm gonna bring a utility math node, and again get it here and divide it by 2 and transform it to the Z. Shift A, vector, combine XYZ. I will not play with the X or with the Y, but the Z, and put it as the translation. And by that I just pushed it to the exact touch point. And now if I increase the depth from the geometry nodes controller here, it increases in one side and it doesn't go to the two sides. Okay, now what else can we control from the group input is actually the scale, which we will call it the offset. So I'm gonna get it here, go to the group, bring it up. So this is the offset. We can call it the offset, the corner offset. And this is the size maybe, or the length of the instance, whatever instance that you put. And what we have else, we can control actually the radius of the points. So if you increase the radius, this is what happens actually. If we increase the point radius, where is it? Sorry. If we increase the scale of these bolts, we can also control the scale. So I will get a vector, but uh, we will scale them in, let's say, in a uniform way. So all what I need here is actually a float number. So shift A, vector combine XYZ, give me the X here, and just let's call it the scale or instance scale, whatever the instance is. In this case it's a bolt, so let me just remove this, no need for it anymore, and bring the scale directly here. Now it's because it's 0, it doesn't appear, so here it is. We can control the scale as well, and with this is how we get it. We can control the length, we can control the offset, so we can put them all in the middle or all into the corners. You can control the minimum and maximum as well, and then you can just give the first one material, shift A, material, set material. You can place any material here, and again any material to the bolts, and with this you can get it as I got it before. Let's bring just shift A, a new mesh, and ecosphere, grab X or Y, whatever. Let's go one, grab X, and apply the same geometry node on it. So I'm gonna select our geometry nodes, okay, in this case, and it should take it as well. Why it doesn't take it? Let's check what's wrong. Low, yes, instance scale, here it is. Okay, the offset, as you can see, there's something wrong in here. Yeah, maybe the instance length, but okay. So let's put it only on the Z. The scale of the instances, yeah, so this should go to the scale here, not the scale there. Okay, that's correct. Now if we play with it the way that we want, okay, and we can place it into the corners or into the center, but it takes it. So that's all for this tutorial. I hope that you have learned something, and thank you for watching. See you later.